Right, so welcome to this video. We are going to look at how we can apply um, mathematics, okay, to pharmacokinetics. Okay, so this is a question that we are going to solve here. We're going to explain clearly what we need to do on each and every part there. So make sure you participate and also ask questions if you don't understand. Okay, so let's start. So the question says, a 65-year-old woman with chronic atrial fibrillation, okay, is administered a loading dose of digoxin, okay, of 0.5 milligrams IV. The plasma concentration measured 1 hour, okay, after administration is 1.0 milligrams per liter. The drug's half-life is 30 hours. Okay, so first of all, before you even solve anything, let's get some information that we've been given from this question here. Okay, so the first thing that we've been given is the dose. The dose of this digoxin here has been given as 0.5 milligrams. Okay, IV. And then what else has been given? The plasma concentration. Okay, the plasma concentration has actually what? Been given. So the plasma concentration is going to be indicated by C naught. So by C naught, we just simply mean C with a zero like that. So the plasma concentration has been given as 1.0 milligrams per liter after what? An hour from when the drug was actually administered. Okay, the other thing that we've been given there is the half-life. So half-life is indicated by T of half like that. So this means half-life. Okay, so the half-life has been indicated as 30 hours like this. Okay, so that is the information that we've been given there. And then the first part here was saying, what is pharmacokinetics? Okay, so we are asked to define what pharmacokinetics is. Okay, so I've written down the definition here that so that you're also able to see. Okay, so pharmacokinetics is simply the study of how a drug moves, through the body. Okay, from the time it is administered to the time when the drug starts to be eliminated. Okay, so that's the definition there, and I've written it down there. So pharmacokinetics is the study of how a drug moves through the body over time. So from the time you take the drug, okay, whatever is going to happen to it in the body, and then to the time where it will start being eliminated, that's what we call as pharmacokinetics. Okay, so in short, I've broken it down here into four things. I was saying this pharmacokinetics describes the processes of, number one, absorption. So when you take the drug, okay, how the drug enters your bloodstream, that is absorption. And then two, that is distribution. How the drug dist how the drug spreads throughout the body tissues once it enters the bloodstream. And then three, metabolism. How is this drug chemically changed in the body so that it can actually help uh, for whatever purpose that that person is actually taking the drug for. Okay. And then after it does the metabolism, the fourth thing there to do is elimination. So how is this drug removed from the body? Okay. All right. So that is what pharmacokinetics is. So in simple terms, we're saying pharmacokinetics is the study, okay, of what the body does to the drug. So you take uh, you take the drug, the body is going to absorb it. After absorption, it's going to distribute it. After it distributes it, there's going to be metabolism of it, and then there's going to be elimination. So that's what we call as pharmacokinetics there. All right, and then the next thing now there was to calculate the volume of distribution. Okay, so before we even calculate the volume of distribution, we must know what is the volume of distribution. Okay, how do we define it? So the volume of distribution is the theoretical volume that relates the amount of drug in the body, okay, to the concentration in the plasma. So now the amount of drug in the body is the same as the dose that you've been given. That will be the amount of drug that will be in the body, right? And then it relates that amount of the drug to the concentration in the plasma. Okay, so meaning that volume of distribution indicated by a V with a small letter d is equals to, okay, the dose, because this is the amount of drug in the body, divided by the concentration in the plasma. So the concentration here, they said it's 1, right? Okay, so anyway, I'm just writing the formula here. So I'll just write concentration like that. Okay, so this is the plasma concentration. So now the dose was given as 0.5 milligrams divided by the plasma concentration was given as 1.0 milligrams per what? Per liter. Okay, so now what I have here is the same as 0.5 milligrams, okay, divided by 1.0 milligrams per liter. Okay, and to be the same as 0.5 milligrams, and then I can say times. Now I change this division to times, so it will be times, and then whatever is down here, which is the liter, will go up, and then whatever is up there will come down. So I'll have like liter over 1.0 milligrams. So you see what happens there, that the milligram and the milligram are going to cancel. Then I'm just going to have 0.5 divided by 1.0 liters. So what do you think I'm going to get there? Okay, so I'll get my volume of distribution to be just 0.5 liters. Okay, so that is my volume of distribution. Okay, volume of distribution is 0.5 liters. All right, so any questions there? Okay, so if there are no questions, we move on to find the elimination constant. So here they're saying determine the elimination rate constant, K. Okay, so what is the elimination rate constant K? The elimination rate constant K, okay, describes how quickly a drug is removed from the body. Okay, so how are we going to find it? We're going to use the relationship of the half-life. So, uh, could you please repeat the process again? Like, I repeat where? Which process? Someone typed in the comment. On B. Oh, you're saying how we found the volume of distribution? Okay, we said volume of distribution is simply equals to, okay, volume of distribution is simply equals to the dose, which was the 0.5 here, milligrams, right? And then I divide this by the plasma concentration, which was 1.0 milligram per liter. So now this per liter here is just the same as I'm dividing this with a liter. Okay, so I'm going to say now I change this sign to a multiplication. So it will be 0.5 milligrams, then multiplied by, this goes to the top, this comes down. So it will be liter on top over 1.0 milligram like that. So now you see that the milligram and the milligram will cancel. So what am I going to remain with? I'm just going to remain with the 0.5 liter over 1.0. So when I divide this, that's how I got my 0.5 liter. Okay, I hope it's clear now. And then now I was explaining on C here. You were saying determine the elimination rate constant. What? K. So I was saying the elimination rate constant describes how quickly a drug is removed from the body, right? And how are we going to find it? We are going to find it using the relationship from the half-life formula. Okay. Someone has raised their hand.
Yes, on the concentration, see initial, isn't the 1.0 milligrams per liter CT because it
I,
was after 1 hour, and then isn't C node like the initial, like immediately, and then after a certain time that will be CT, which is the final
oh, yeah.
concentration.
Oh, yeah, yeah, yeah. Yeah, I think I didn't get that one. Yeah, so the C naught must represent the initial concentration, right? Okay. Yeah. So she's talking about the notation that I used here. Saying the C naught here must be like the initial. But this plasma concentration here was measured after an hour. So the notation that we use there will be like CT. So after time T, which is just 1 hour. Okay. Anyway, but the answer that you're going to find will still be the same. Okay, so now let's find the elimination rate constant K, right? So the elimination rate constant K, we're going to get it from the formula for the half-life. So now, pharmacokinetics, okay, most of the processes, they follow the first order kinematics, okay? So the first order kinematics, the formula for the half-life, okay, I don't know if you've learned this thing in chemistry already, but the first order kinematics, the half-life, okay, is given by T half is equals to ln of 2 divided by K. So now this T half here is just the half-life. And then ln of 2 is a constant. So you can even punch it on the calculator. It gives you a 0. Let me do it. So ln 2 gives you a 0.9, 0.691 4718, something like that. So here my aim is just to make the K the subject. So I cross multiply, got to have K half-life is equals to ln 2. Then I divide both sides by T of half. So meaning K is equals to ln of 2 divided by the half-life. Okay, so this will just be equals to. So now my half-life has been given as 30 there. So I'll say 30 hours and then divide this by, okay, divide this by, uh, oh, sorry. This is ln 2 and then divided by the 30 hours. Okay, so what are we going to get there when we divide? So my K will be equals to, so I just punch that on my calculator. So I have ln of 2 divided by 30. So that gives me 0.023104906. Okay, and I'm going to have divided this over an hour, okay, because the hour was in the denominator, but we can write it in a simple notation. We're just going to say hour to the power minus 1 like that. Okay, and then we can just round off this answer to a reasonable number of decimal places. Okay, so for this one, I'll say 4 decimal places will be reasonable. So my K will be 0.0231 because this 0 is less than 5, so I can't add anything to this. And then hour minus 1, or you can say per hour. So this one here is my elimination rate constant. Okay, so any questions there? Okay, so if there are no questions, we go to D. So D says calculate the clearance. Okay, calculate the clearance. So what is the clearance? Okay, so the clearance is the volume of the plasma cleared of the drug per unit time. Okay, the volume of the plasma cleared of the drug per unit time. So meaning that the formula will be, the clearance will just be equals to, okay, remember we said this elimination rate is describes how fast the drug is being removed from the body, right? And then now for clearance, we are saying it's the volume of the plasma cleared of the drug per unit time. So meaning the clearance, okay, is simply equals to the K multiplied by the volume of distribution. Okay, so this will be equals to the K, I have 0.0231, okay, per hour like that, multiplied by the volume of distribution is 0.5 liters. So what do I get when I do this? So this guy multiplied by the 0.5, I get 0.01155. Okay, and then I have the liters divided by the hour. So this would just simply be 0.01155 liters per hour like this. Okay, so that would be my clearance there. Yeah, so if you want, you can round it off to 4 decimal places. It will be 0.011, and then you have a 6 there. It's also okay. Okay, but there, I'm just going to leave it the way it is. All right, and then we look at the last part, which is E. So let me write here. So clearance, we found it is 0.01155 liters per hour. Okay, what about now part E? So part E says if a continuous IV infusion of 0.02 milligrams per hour. Okay, so since this has the time to it, it means it's a rate of something, right? So 0.02 milligrams per hour is started. What will be the expected steady state concentration? Okay, so now what is this steady state concentration, right? So the steady state concentration is the drug concentration reached when the rate of the drug infusion is equal to the rate of the drug elimination. So if the rate at which someone is putting the drug into this patient is equal to the rate at which the drug is leaving that patient, okay, that situation there, the equilibrium that is reached there is what we are calling as the steady state concentration. Okay, so steady state concentration, CSS, is given by the formula R, uh, R naught there, and then divided by the clearance. So now the R naught here represents the infusion rate. Okay, to represent the infusion rate. And from part E here, they've said if a continuous IV infusion of this. So this is the infusion rate. So R naught, we're just going to say it's 0.02 milligrams and then per watt per hour. And then the clearance, we've already found it to be 0.01155 liters per hour. So let's find the steady state concentration. Okay, the concentration when the rate of the drug infusion is equal to the rate of the drug elimination. So like we have reached like an equilibrium. So this will be equals to, okay, I'll write it as 0.02 milligrams per hour divided by the clearance. It is 0.01155 liters per hour. Okay, so this will just be 0.02 milligrams per hour multiplied by this hour goes on top, and then down there I have 0.01155 liters. So you see that the liter there, okay, the liter there and the liter there will cancel. So what I have is that my steady state concentration will just be 0.02 milligrams divided by 0.01155 liters. So what is left is just to punch whatever I have here on my calculator. So this will be equals to, okay, so let me do that. So 0.02 divided by 0.01155. So that is giving me what now? Okay, it's giving me 1.7316011734 and then milligrams per liter. Okay, so we just round it off to a reasonable number of decimal places, or you can actually follow this one, which has the least. So let's say we round it off to 2 decimal places. So it will be 1.73 milligrams per liter. You can see that even the units here are confirming that this guy is a concentration. Okay, so the steady state concentration there will be 1.73 approximately. Okay, so when the concentration reaches at that part, at that point, okay, then to mean that the rate of the drug infusion is equal to the rate of the drug what? Elimination. Okay, so thank you so much for watching this video. If you'd like to access full solutions to that paper, you can subscribe and access them at discretelearning.com. Again, if you're having challenges with your pre-med or your NS, okay, in any of these courses that I've listed here, biology, physics, chemistry, or math, okay, I would like to tell you about a platform that can be a solution to you. So that platform is discretelearning.com. Okay, so we have both the website and the mobile app, And these platforms have videos that can actually help you to better understand whatever you learn in class and just show you a simple way in which to answer questions. Okay, so you can subscribe and get help in any of these courses: biology, physics, chemistry, or mathematics. Okay, both semester one and semester two. So for whatever course you register for here, you're going to access tutorial sheets, full videos for tutorial sheets. You're going to access full videos for assignments. You're going to access full videos for past quizzes, for past tests. Okay, you're going to access full video solutions to past mid-semester exam papers and also final exam papers. Plus, okay, you have an opportunity to consult from us. So maybe if you are watching one of our videos and you do not understand, you can simply inbox us to consult on that particular question. Then we'll be able to help you. Okay. And a bonus is that we also have live classes. Okay. So these live classes, we explain concepts to you on a live class. So meaning you're able to we're able to interact with you and you're able to ask questions there and then so that you understand the concept. Okay, and our videos are basically tailored to your university syllabus. Okay, so we are teaching what you need to know in order for you to actually pass and get to understand these things very easy. So I'm just going to show you that we have solutions to, for example, I'll say all the math tutorial sheets. Okay, it's the same in chemistry, the same in physics, the same in biology. So when you come here, math tutorial sheet one is on algebra. So all these questions here were solved in a very simplified way that you can understand. Okay, so all these questions here in tutorial sheet one were solved, and the videos they are available on the website. You can watch at your own time, at your own pace, even in your blankets. Okay, tutorial sheet two is on exponentials and logarithms. Again, we solved all these questions that you can see in this tutorial sheet too. And the videos are waiting for you on the website. Okay, so once you watch these videos, you understand the concepts clearly and you'll be able to answer questions in your assessments, like the quizzes, the tests, the mid-semester exam, even the final exam. Okay, there's also tutorial sheet three on functions. Again, we solved all these questions here. Okay, how to limit the domain, how to sketch the functions. We talk about the quadratic functions. Um, and such things. Okay, all those questions have actually been solved. How to find the composite here, all these things we've solved. The videos are there available for you at any particular time. Okay, so that was tutorial sheet three. Tutorial sheet four is on sequences and series. Again, we've solved all the questions in this tutorial sheet. Okay, all the questions here have been solved. They're there. You can access them on the website. Tutorial sheet five, differentiation and integration. This is a topic that most students find difficulties with or challenges. Okay, we've solved. Okay, I've shown how you can differentiate in a very easy way. Okay, so how many questions did this tutorial sheet have on differentiation? It had how many questions? 5 questions. We've solved all of them and you can access them on the website. Tutorial sheet 6 is on descriptive statistics. Again, we've done justice to this tutorial sheet. We've explained all the concepts clearly and you can access them on the what? On the website. Okay, so all these questions have been solved. Tutorial sheet 7, which will be the last tutorial sheet on probability for semester 1, okay, has also been solved. So all these questions that you can see here have actually been solved and they're available on the website. Okay, so in addition to the tutorial sheet, guys, you get to access the past papers, the quizzes, the tests, the mid-semester exams, the final exam papers. You get to access them, okay? And also the topic lessons so that you understand the topics fully. They are all available on our website. So we also have this assignment one here. It was solved. Okay, so assignment one had like 2 questions. There's this one on pharmacokinetics. We solved it. And then question 2 is on exponential decay and growth, okay, of bacteria. We've solved all these questions here and they are available on the what? On the website. So if you need help in any of those courses that are actually listed here, biology, math, physics, chemistry, you can subscribe at discretelearning.com and you're going to access them. So you can contact me on these 2 numbers here, okay, if you want. Again, let me just show you the website for those who have never seen it. So you just go to Chrome here and then type in discretelearning.com. So you can see the discretelearning.com there and then go search. take you to our website. So here, if you don't have an account, you need to create an account. So you just go to start learning now. Okay, then it will take you to the login page. So if you don't have an account, go here, create an account, and then log in. But if you already have an account, just put your email, your password there, and then log in. Okay, after you log in, these are the things that you're going to see. So you can see mathematics, chemistry, physics, biology, everything that you need uh, to help you. So for example, I'll just use the math folder or the math course. If you open it, you go to your particular university. Okay, so if you're from Unilas semester, first semester, you go here. Unilas second semester, you go there. But if you're from any other university, you go in general mathematics. If you're from Apex, you use those. So I'll just use the semester ones here. So if I click on the semester one, you see that it's going to open and I'm going to have four folders: topic lessons, summarized, tutorial sheets, past quiz test, and exam paper. So if you go, for example, in the tutorial sheets there, okay, you're going to find videos for all the tutorial sheets. So you go to your intake. Okay, so the current intake now is 2026 January. I'll go in the 2026 January there. Okay, and you're going to see here the assignments are there and all the tutorial sheets are there, so you can learn and I mean you can watch and learn from these videos at your own particular time. And if you have any question, you inbox us. Okay, so my number for those who want to register is 0779 96 40 10. So that is Tutor Pro Solutions. Okay, but if you just want to self-register, you can check the registration video guide in the description below here. It's going to show you how you can create an account on the website, how you can register, how you can pay and access these, okay, automatically without even needing any of my team members. All right, so thank you so much for watching. This has been Tutor Pro Solutions. Until next time, always there for you, and I wish you all the best in your exams.